Relative velocity is really only understood once you've been able to do some practice problems, so here we go, a little bit of practice. Tom is jogging on a treadmill. The velocity of the tread is 1.25 meters per second to the right. So the tread, what he's walking on there, is moving to the right 1.25 meters per second. Okay? Tom is jogging to the left. 1.25 meters per second. Now we just saw in the notes there that right and left, those are opposing directions. When that happens, you need to give one of them a negative value. So the one going to the left is usually the one we make negative. So Tom has a negative 1.25. That's telling him is going to the left. Now the question is, what is Tom's velocity relative to the ground? Okay? So relative to someone standing right here on the ground next to the treadmill talking to Tom, how fast is Tom moving? Well, relative to that person standing right there, Tom's not moving. 1.25 meters per second to the right, the negative 1.25 meters per second because it's going left. We have a 0 relative velocity. Now, what if Tom gets distracted? Tom gets distracted, he's not paying attention, and someone turns up the speed on the tread. Okay? So, they start off with the same velocity. Those arrows are the same length. Same speed, opposite directions. What if someone increases the speed of the tread? Well, if you increase this number right here, the 1.25, let's say we make it 1.5, increase it just a little bit. This is no longer going to be 0. He's going to start moving backward and fall off the back of the treadmill. Okay? So that's what we're talking about here with relative velocity. Those opposing velocities, we can subtract them and get the relative velocity to the ground. Okay? Next example. Maria's on a train. The train is moving 25.8 meters per second north, and Maria walks south on the train at 1.5 meters per second. So, 25.8 meters per second going north. That's the train. Maria's on the train, and she's walking the opposite direction the train is moving, but only at a speed of 1.5. Okay? Opposite directions. I want to know Maria's relative velocity relative to the ground. So, velocity relative to the ground outside. 25.8 north. We'll make that one positive. So we're going to make the 1.5 negative because it's going the opposite direction. All right. 0.8 minus 5 gives us 0.3. We end up with 24.3 meters per second north. Okay, so Maria, if you look at her, if you put a speed gun on Maria, and you could separate her from the train, she'd be going 24.3, even though the train would be going 25.8. Because her little bit of walking going the opposite direction, she actually is going a little bit slower relative to the ground outside. All right, now we have Jose kayaking. He's kayaking with enough force to move at a velocity of 3.6 meters per second to the left. His arms, force, everything says he is doing 3.6 meters per second to the left. However, the river below him is flowing 2.2 meters per second to the right. Okay? Allison is on the shore, and she's going the same speed as Jose. So, what is her velocity? What we're actually asking for is what's Jose's velocity relative to the shoreline, relative to the ground beside the river. So here we go. 3.6 meters per second. That's our negative value because it's going to the left. 2.2 meters per second to the right. Okay? He's basically rowing upstream. Okay? If you're rowing against the current, you're not going to go as fast as your arms are propelling you. You're going to be going slower. So we end up with a negative 1.4 meters per second. Negative means he's moving to the left. So 1.4 meters per second left is how fast he's going relative to the shore, or in other words, how fast Allison's going, because she's running alongside. All right, flock of geese flying 5.2 meters per second south for the winter, and that's their speed relative to the ground. So this is them relative to the ground. 5.2 meters per second south, relative to the ground. There's a 2.1 meter per second breeze going south. Okay? 2.1 meters per second. This is the wind. How fast would the flock of geese be flying without the wind? Okay? So the wind is kind of like being on a river and going downstream. It's pushing the geese along. If there wasn't a river, if it was just a lake, how fast would they be going? That's kind of the idea. Okay? So, what two velocities would you add up to get the 5.2? Because this is the geese plus the wind. Right here, this is just the wind. So the question is, how fast are the geese going if there was no wind? Well, you'd have to add these two together to get that value of 5.2. So, in this case, it's 5.2 is minus 2.1. 3.1 is how fast the geese would go if there was no wind. So 3.1 meters per second south. Okay? Relative velocity is one of those things where these problems, you have to read them carefully. I recommend that you draw arrows, make those arrows of relative size compared to the speed, and that will help you get some idea of how to work these things out. There you go.